Here we're going to look at one of the types of reactions of alcohols, which is oxidation. In the laboratory, we commonly use potassium permanganate or potassium dichromate for these. So potassium permanganate is a purple or pink solution, and here I have got some ethanol with that, and I've acidified it with sulfuric acid, and you can see that it's starting to take away the purple colour at the top. Ethanol is less dense than the two things we're working with, so its concentration is a bit higher at the top. So the observation we expect to see with an alcohol is that it goes from purple to colourless as the manganese 2 ion is formed. Manganese 2 is technically pale pink, but it's so pale we usually can't see it. The other reagent we commonly use is orange potassium dichromate, and in this I've added this quite a while ago and it's starting to go a greeny yellowy sort of colour. If I leave it long enough, or if I was to add some heat to speed up the rate of reaction, this will actually go a bluey green colour. So we can either use permanganate going from purple to colourless, or dichromate going from orange to a green or even a bluey green. What's happening is that the alcohol is being oxidized. Now, only primary and secondary alcohols can be oxidized, and this is because they have the ability to lose H+. Whereas in a tertiary one, there's no H coming off the alcohol carbon, so it can't lose H+, so it can't be oxidized. So this is a really good test to tell if an alcohol is a tertiary or not. Tertiary alcohols do not react with potassium permanganate or potassium dichromate, so you won't see these colour changes. What's being made? Well, if I start with a primary alcohol, first of all it becomes a chemical called an aldehyde, which basically means an alcohol without its hydrogens. That's basically what the name means. Then if I have enough oxidizing agent, it will carry on to become the carboxylic acid. So the example I've got here is with 1-propanol, where it loses these two hydrogens here, to become propanal. Then an oxygen is added to it to make propanoic acid, the 3-carbon carboxylic acid, which we'll learn about in a later part of the unit. The secondary ones become something different, but we still get the same observations. So it's hard to tell primary and secondary apart using oxidation alone. We normally use something else, which is the Lucas test. Secondary alcohols go as far as a ketone. Again, the same colour changes, purple to colourless or orange to green. But in this case, I've used 2-propanol as my example. These two hydrogens are removed to make propanone, but now there's no hydrogen like over here to add in an oxygen. So that's the end of that reaction. It won't oxidise any further. So these are some examples of oxidation of alcohols using our two most common laboratory oxidizing agents, permanganate and dichromate. You don't need to know the names of the things that they become. That comes in level 3. What you do need to do is know how we use this to tell if we've got a primary, secondary or tertiary alcohol. As I say, this won't tell us if it's primary or secondary, but it will tell us if it's tertiary because no reaction would be observed, no colour change.